Hey, hello guys, everyone. Welcome to our channel. And as I promised that I will bring practice set of the for CSIR-NET June 2023 for chemistry. So now I am here with the session of quantum chemistry, that is 10 question series. I will start from today, and up to last date of your means your CSR date already announced. I think 6 to 8 in between your exam will be held, and up to 7 I will try to upload a 10 question series, or if you comment me, then I will make more questions. But now I am targeting 10 questions from each topic, so you can memorize your formulas and all the other things, means concepts, and practice. If you watch this video, just you can memorize your things, and the concept will be again and again refresh your mind, so it will be very helpful for you. Hope you will like this video. So without wasting any time, I starting with the simple questions, and I'll do here 10 questions. But if you like my video, means if you comment that you want more questions, I'll try to make more questions. Okay. So thank you. Now come to the main thing, that is here. You can read the question. Sorry about my handwriting, because I'm not habituated with this pen tab. I am habituated with board. So, but focus on the concept, not on other things. The probability of finding particle in a one-dimensional box of length L in a region between L by 4, 3L by 4. This is the lower limit, and this is the upper limit for the quantum number n equal to 1. So they are telling that it is a one-dimensional box and length of L. Okay. So first thing, the key points of from the questions, that is one-dimensional box, and and here the length is between region is between L by 4 and 3L by 4, and the quantum number is n equal to 1. So you know that psi n equal to root over 2 by root 2 by L sine n pi x by L. Okay na. So this is for 1D. Okay. So here they already told that this is here n equal to 1, and so we can write it root over 2 by L sine pi x by L. L is the length given. Now they want to know the probability. So you know the probability formula. Probability density is the psi star. Okay, and psi star, and probability is equal to psi star d tau. Okay, so this is probability, p equal to probability. Okay, probability. So now here psi is root 2 by L sine pi x by L into psi star, means it conjugate. Here is no I is present, imaginary anything is present, so same we will write the same, psi equal to psi star here. So root 2L sine pi x by L here in the form of x, so dx 1D. If there will it is 3D, we will write that dx dy dx, but it is 1D only x, so we are using dx. So how to do this? And here the lower limit is L by 4 and upper limit is 3L by 4. Okay, so now this is the constants, that is we can write 2 by L, L by 4, 3L by 4 sine square by x by L. So here we can write, see, you know that cos 2 theta equal to 2 cos square theta minus 1, or we can write 1 minus 2 sine square theta. So 2 sine square theta means 1 minus 2 cos theta. So 2 sine square theta, little bit mathematics is required, not that one. 2 cos theta, and here so we will use this 2. So 1 by L, first we can write this 1 minus 2 cos theta. I am separating this at a 1 because you don't want to means there is a very less time, so you have to do calculation, you can skip the steps as well. So you can write directly that 1 here means dx, we can write minus summation of cos 2 theta. 2 theta means this one, so 2 pi x by L, and this is the L by 4, 3L by 4. Okay, so 1 by L we can write here 3L by 4. Okay, see here x is will come, L by 4 will come, simple integration. So what is the integration of cos? That is what is the integration of cos? That is sine, not minus. The differentiation is minus, but the integration is opposite. So half 1 by m sine 2 pi x by L, same L by 4, 3L by 4. So from here you can see that we are getting, so this is taking so much time. After solving it, we are getting here, you can see here x means 3L by 4 minus 1 by 4, and you have to put here higher limit sine 3L by 4 and L by 4. So we will get here half plus 1 by 5. Oh, why half? Here you can see that 3L by 4 minus L by 4, that is 2L by 4, and here 1L is outside, so L cancel, so half, here half is coming from here, and 1 by pi is coming from there. Okay, this is the answer. I am taking so much time, I know, but be patient and watch till the end. And yeah, I already uploaded one video related how I cleared my JRF last JRF, and what was my strategies, and how you have to prepare, or how last month strategy, and everything I discussed is a long video. Please watch that video. I'll put the link in the description box. So I think you will get some tips or some important topics that will help you definitely. I'll put the link in the description box, you can watch that video. So coming to the next question, I am not wasting too much time because the video will be too much long. So coming to the next question, a particle in the three-dimensional box you have to see the keywords. Particle in 3D box and length of L has energy is here. The degeneracy of the state. So I think most of you can do this problem, but let me do. I think if you have any doubt, it will be clear. So so you have to watch the keywords of the questions. Like here, three-dimensional box is given, and length is L, and the energy is 14 h square by 8 ml square. So for 3D, what is the energy? En equal to, that is n x square plus n y square plus n z square into h square by 8 ml square. So we can replace here this, sorry, we can replace this one with 14 for n x square n y square n z square equal to 14. So we have to take the summation of the squares. So how we will get this? Try alternative things, like if I take 1 square, if I take 2 square, what how much are we getting? 1 plus 4 5, we need 9, means 3 square. So the energy state will be 1 2 3. So how many degeneracy we will get? How many configurations we will get? That tell me. We can write 1 3 2, similarly 2 3 1 2 1 3, same 3 1 2 3 2 1. How many? 6. So how to remember? Don't waste too much time. In exam you have to be quick, because you need marks, not you have to clear. uh, you don't have to show your rough page to the examiner or the scrutineer. So you don't want to explain how much you know, but you have to correct the question. So be tricky in the examination, but for practice you should clear your concept. But in exam, as much you can tricky, so you have to be tricky and fast. So here for if the three numbers like a degeneracy numbers both are similar, so we will get only one degeneracy. This is degeneracy. If uh, there is only, means two is common, means here you can see two numbers are common, so you will get 3. And if the three of them are different, then you will get 6 number of degeneration. So I think you cleared these things. If the three are of them same, then we will get one degeneracy. Means degeneracy means what? This the we are getting only one energy level. Means like 1 1 1, 1 square 1 square 1 square. So the energy will be 3 8 square 8 ml square. Means we have the same energy state, same of three of them in a same energy level. If we will draw this, here we are getting means sorry, 1 1 1 means only we will get sorry, one degenerate state, means the number is same. Here 6 degenerate state, means we will get for like here 1 2 3, we will get 6 of them are in same energy level. For 2 2 1, suppose, for 2 2 1, suppose, for we are getting 3 energy states. 2 square means 2 square 8 plus 9 means 9 8 square 8 ml square. This is suppose this is the energy curve, energy uh, diagram. So this at this point means 9h square of this energy, we have three states, three degenerate states. So molecule or the particles can stay here, means according to the spectroscopy. If we read the molecular spectroscopy, the molecules state are like this. Or if we are studying electronic spectroscopy, the electronic states are will be like same. Okay, so okay, coming to the next question. I have to be little. So read the question carefully. Here here is wave function is given, that is already normalized they told, and it is a diatomic for molecule. That's why two wave functions constructed by phi a and phi b. So as they told that it is normalized, we can write like this: C1 phi 1 plus C2 phi 2. As they told, like means it is normalized, so we can write that C1 square, the C2 square plus 2 C1 C2 into S equal to 1. 1 because they told it is normalized. So what is S? S is the overlapping integral, that is here is they told overlapping integral. So here they want to know this thing. Simply we will put this value here and we will get the answer. So 0.88 whole square. I want to be quick because I am wasting too much time. I think 2 of 0.8 into 0.4 into s equal to 1. So we will not talk too much. I will start. We will focus on the problem and the questions only. So that is 0.64 plus 0.16 plus 0.3 to 0.64 again 0.64 is, so sorry, equal to 1. So 0.644 is equal to 1 minus 0.8, that is 0.2. So is equal to 0.2 by 0.64, that is 20 by 64, that is 5 by 16. So 0.31. This will be the answer. S equal to, it's a pure mathematics. If just you want to know this thing, that we are writing as a wave function, that is psi in form of psi, a coefficient into the wave function of first of one atom. Then another coefficient with its wave function b. Here we can replace it a and b. And as they told, it is normalized. If they don't say nothing is told, we take it a normalized function. Otherwise we can't evaluate the value. So c1 square plus c2 square, this one equal to 1, and you have to calculate this as well. That's it. Now coming to the next question. Okay. So for a particle in a box, the problem in a 0L value, that is average value of xq, you have to evaluate. So as I told, in your exam you have to be tricky. So we can put you can take a short trick of this formula. If they are asking about x to the power n, average of x to the power n, you can put like this, that it will be, the answer will be l to the power n by n plus 1. This is the short trick. This is the short trick of this average value. So this is the short trick. Otherwise you have to do a long calculation, like if you want to evaluate the average value, you have to take like this, that is integration of psi uh, x cube. This is a in between function, and psi star d tau or dx. Okay, and you have to put the psi equal to root over of root 2 by l sine n pi x by l, and psi star as well. That then you have to do a long calculation and you will get the answer. So here is a short trick, to save your time in the examination hall. So as per this question, we are evaluate x cube equal to, means l to the power 3 by 3 plus 1 means 4. So please remember these questions, means these three. Along with that, I am telling one thing, that I will share my short notes, my short notes as the form of video. For all the topics. So if you are, means before going to bed, you can see one half an hour video, that that will help you. Means before sleep, if you read anything during your sleep, it will means it will be in your mind. You can means memorize that those things. If you study something and if you sleep, your dreams will come like that, or means in your mind the calculation will going on and the thinking are coming like that. So it will be helpful for you, I think. Just don't waste your time. Study as you are studying for solving questions and everything. But before going to bed, you can watch the short note videos. I will try to upload. Because of some busy days, I didn't upload this video of question answer, but I will try my best. Before your exam, I will try to upload all the videos. So now, without wasting, I am going to the next question. I am talking too much. Okay. So here the next question: the energy of the hydrogen atom in a state is, that is minus of HCRH by 25. The degeneracy, they want to know the degeneracy. Okay, we know that the energy of the hydrogen atom, that is minus of RH, minus of RH z square by n square. So in here RH, the everything is coming. This is the constant, Rydberg constant, and as it is a hydrogen atom, z equal to 1 and n square equal to is given 25. So there is a formula of degeneracy, that is degeneracy equal to n square. So that is you can, I think you can get the answer, that is degeneracy equal to 25. But if they are asking like spin included degeneracy, spin included degeneracy, that will be 2n square. Remember this thing, huh? If they are asking about only degeneracy, they are asking about only degeneracy, then that it will be n square, but if the spin is included, then 2n square it will be the answer. So here answer is the 25. So coming to the next question. Okay, this is a very tricky question. You can see here, you can see that a one dimensional quantum harmonic oscillator is part of by the potential is lambda x cube. As the first order correction, the energy of the ground state is, that is first order energy correction. What will be the answer? So here also some tricks are there. I will tell the tricks. If the power is given here odd, means x to the power n, if it is odd, then there is two things we can say, means it uh, for remember for 1D SHO only. Okay, what we can write? First thing is, note this thing. First thing is first order correction. Order correction, that is delta E equal to 0. Another thing, what happened? Okay, another thing is second. Note these things in your notebook. Second order correction. I'll share the short notes before your before one week of your exam, or 2 week of your exam, that you can memorize your formulas and concepts. Okay. Now I am trying to solve the questions answers. 10 questions are very difficult to pick, but I choose 10 questions. If you want, I can share more. So that is, it will be negative. So it is the one condition. It is also a calculation of means as ground state is taken psi 0, then the function lambda x cube, then again psi 0 star d tau. Okay. So we have to calculate this, and a very long integration is there. So instead of doing that, we want to save our time in exam. We want to solve question. We want to crack JRF. So here, if the power of x, lambda is a constant, if the power of x is odd, for 1D SHO, this is also for applicable for 1D SHO, simple harmonic oscillator, quantum harmonic oscillator. First order will be correction will be 0, second order correction will be negative. Okay. Okay. So going to the next question. Okay, sorry. Huh. uh, Vibrations of a diatomic molecules are usually modeled by a harmonic potential. If the potential is given by x square, the value of the force and the force constant. I think you know about the force constant, you heard about that. Okay, so that is F equal to minus kx. You heard this is a spring constant. You heard about that, I think, for spring constant. That is also applicable here. Okay, so we have to, as they are asking about the potential, you can see potential, they mentioned the potential. We know the potential Bx equal to x square. X square potential is given, x square it is given actually. So we have to take the force constant from here, means as we know F equal to minus kx, and F equal to minus of d dx of Vx, as we know this. The differentiation of the potential is the force. Okay, so as per the concept, bx we can write x square as given in the formula, sorry, question. So minus of 2x. So if we compare this, f equal to minus 2x, what will be the force constant here? 2. I didn't mention the options, because I think during practice you should not take options, means then your mind will think in between only the four options. Your mind will run only between the four options, and you will try to calculate the or evaluate the answer from the options only. But I think in during practice you should only focus on question, not on the options. In exam you can focus because you want to crack this GRF, or you want to be fast. We can take you can evaluate the answer from the options as well. But in when you are doing the practice, you should use your mind and think. You should use your brain, then your brain will be sharp, and it will work more in examination than other students. So don't mention the options. If you are practicing, don't watch, only focus on the answers and try to think about it in your mind. Okay, so the answer will be 2, k equal to 2. The force constant, they want to know the value of the force constant is 2. Okay, coming to the next question. Sorry. Okay, read the questions. Given a trial wave function that is psi 1 equal to c1 phi 1, that is a wave function of two, I think, diatomic molecule. The Hamiltonian matrix is given is here, and here this question, if you don't know, you can't do. Here is something I have to tell you, that is you want to, you have to remember one determinant, that is secular determinant. If you have to calculate this is a this we got from the quantum calculations actually. If you study quantum detailedly, it is there only. If I teach you, I will definitely tell you, but now focus on the trick how to solve these questions only. So remember this secular determinant, that is H means it's a matrix. E is 1, and that is 1 2 minus E is 1 2. See, it is like that only, H minus E is. So you are writing like this, 1 1 1 2 2 1 2 2 as the rule of the matrix, and the values are given that, sorry, this is 2 1, sorry. So 2 1 H 2 2 minus E is 2 2. This will be have to be 0. So how we will get these values? Means here you can see 1 1 means H11, that is given equal to 0. 1 2 means H of 1 2 equal to 2.5, and here 2 2 H22 is given, it's 12. Okay, another thing you have to remember, that S11 and S22, S11 and S22 equal to 1. You have to remember this. Why 1? You can see that same wave function is there, that is a normalized, that's why 1. and S12 equal to S21 equal to 0. Okay, this is normalized, that's why 1. This is orthogonal, that's why 0. I think you know what is normalized function, what is normalized and what is orthogonal rules. You can read the quantum mechanics. If you know, it is good. So you have to put these values there. So now we are going to put here. So H11 equal to 0 minus E. Here 2.5. H12 equal to 2.5 and S12 equal to 0. S21 as also 0. So this is also 2.5. So I forget to tell that H12 and H21 values is same. Here you can see that if we change the position, it will be same actually 2.5. So that's why I am taking it H21. Okay. So don't confuse. Here I put the value of 21 here, and S21 equal to 0 I already told. So only 2.5. I can write here minus 0. It is also 0. H22 is 12 and minus E into 1. So these are the things. So now simple determinant rule, diagonal will be multiplied minus of this. So minus E into 12 minus E minus 2.5 in square, 2.5 into square equal to 0. So E square minus 12B minus 6.25 equal to 0. Okay, so this is now you have to calculate the E that I already calculated. I don't want to waste time. Okay, minus B plus minus root over of B square minus 4 AC by 2A, that you have to put and match your answer. That will be, I think, minus 0.5. Okay, calculate it and match the answer. Don't be lazy. Now coming to the next question. Last two are remaining. Don't worry, don't be lazy, don't be impatient, be patient. So the ionization energy of the hydrogen atom in its ground state is 13.6 eV, and the potential energy of the helium plus ion in GS approximately what will be the answer? So ground state, the energy equal to, ground state the ionization energy equal to, okay, let's see. I want to tell one thing, that the energy of the hydrogen atom, the means that is, the formula is En equal to 13.6 Z square by N square, that is the energy. But the ionization energy will be just change the sign, 13.6, because you are removing the electron from the atom, so you have to keep energy, so that's why it is positive. Now what is the question? We are not going that, we are focusing on the helium. So forget these things, these are not the question actually. We have to focus on helium atom. there. Okay, so here of He plus 13.6, what will the z is equal to 2, so 2 square means 4 by He plus 1 means 1, so n equal to 1, that is 1, and we can write what 54.4, that is in EV unit. But this is the energy of the helium atom for only one electron system. Okay, they are asking the potential energy. I think you know the means if you know the relation, total energy equal to E total equal to E potential E kinetic energy plus EP energy potential, and potential energy equal to twice of the kinetic energy minus, and the kinetic energy equal to the total energy. So we can write here, you can see that Ek minus of 2 of Ek, so that is minus of Ek. So the total energy equal to minus of Ek. So we can write that the potential energy equal to twice of the total energy, and total energy is what? Total energy we calculated from here. So simply we just put, don't be confused, I will tell again, no problem, or you can rewind the video. So 54.4 EV, so that will be 108.8, I think that will be the answer. I didn't mention the options here, but it will be the answer. Here I am telling again that, listen, one question is left, I think. The total energy is equal to the potential energy plus kinetic energy. Is this true? This is true, and you have to remember this, that potential energy is the minus of twice of the kinetic energy. So I am putting here the minus of twice k and Ek, that is total energy equal to minus of potential energy. So so here I put the value, actually means minus of 2 minus of E total, that's why we get 2 into E total. Okay, I think it is clear. If you not clear, comment, I will tell again in the next video. Now only one question is remaining, it is final question. This also some tricks are there, I will tell you the whole things. Okay, read the questions carefully. Here, as I think you wrote the question that we are doing correction yielding first order correction E1, and E0 is the ground state energy. So ground state energy is E0, that is GS, and the first order, the GS certain energy system, that is E, and we are that is subjected to perturbation of V yielding the first order correction, that is E1. So they are asking that what is the relation between this and this. So one thing you have to remember, that if we are doing any correction in energy, means if we are doing, note the line, if we are doing any correction in the energy, the corrected energy must be greater than equal to the ground state energy, means the actual energy, not ground state, the actual energy. actual energy. And second point is this is first point, you can note this. Second point is, as many as correction we will do, the energy will be closer to the actual energy. As many as corrections we do, we come more closer, more closer closer to the actual energy, but it will be always greater equals to the actual energy. So as many as correction means, if you see the corrected formulas like e plus some x function, again some x function, again some x function, so it will be more closer to the ground state energy than the less corrected functions. So here the answer, I think you already know that. Here it is already, I wrote that. You can note these things. That is here, uh, take the black one. Okay, here the energy is always greater than equals to the ground energy. Okay, this is the answer. I think this is a final question, and hope you like this video. It will and hope it will help you in your CSIR-NET examination. I'll try to come with another topics. With this 10 question series, I will complete with in from every topic. And if you want more questions from quantum mechanics, quantum chemistry, I'll bring. Just comment below, and I will try to bring. Okay, and I will share my short notes just before of 1 week or 10 days of your exam. Thank you for watching. Happy learning, and have a nice day.